All right, this next example is going to look a little bit different from the previous ones. So let's find a limit as h approaches 0 of the square root of 16 plus h minus 4 all over h. So directly from the start, if we were to substitute in 0 for h, we get 0 in our denominator. And thus we cannot evaluate that limit because we would have something that is undefined. Now, the idea behind this is, well, is there another way that we can actually simplify this so we don't have to worry about maybe that h anymore? And I know you've heard of this before, but maybe you didn't hear about it in this sense. So we've all heard of the term rationalizing the denominator. Well, nobody says you couldn't do the same thing to the numerator. So let's go ahead, let's rationalize the numerator. Let's see what happens. Because you really can't factor anything, and nothing else simplifies. So this is the only thing I think of when I see square root symbols. I think rationalization. So I'm going to multiply the numerator and the denominator by, does anybody know what this is called? Hopefully you were thinking conjugate. All right? So multiplying by the conjugate is actually very nice. In the numerator, since they are conjugates, I don't have to multiply everything out. I don't have to distribute everything. All I got to do is multiply the first terms. That's going to give me 16 plus h. And then the last terms, and that's going to give me minus 16 all over h. And I'm going to leave this the same, and you're going to see why in 1 second. So h times the quantity, square root of 16 plus h plus 4. Notice in my numerator, I can simplify 16 minus 16 is just going to give me h. And hopefully now you can see why I left my my denominator completely factored. It's because now the h's reduce. So my h's reduce. That's going to leave me with a limit as h approaches 0 of 1 over the square root of 16 plus h plus 4. Now if I use direct substitution, I get 1 over the square root of 16 plus 4, which is 1 over 8. So a problem that initially looked kind of complicated because of the square root and everything actually turned out to be very simple, provided you remember all of your algebraic techniques, which I got to be honest with you, we use a bunch of them in calculus. So make sure you review all of that stuff. And if you ever get stumped or something like that, do not, do not allow yourself to go crazy. Don't worry. You know what I mean? Don't worry too much about it. Ask me a question. That's all you gotta do. Just email me and say, hey, I'm having problems with, factoring or something like that, and I'll be more than glad to help you out. Okay. The last example we're gonna look at in the next video deals with a very powerful technique called the squeeze theorem. So I'll see you in the next video.